Hello everyone. I am now going to deliver my fifth lecture series of the seismic, namely this classification of folds and faults. So all my previous lectures of the seismic series, I have illustrated about geophysical lectures, the classify everything. That means seismic basic principles and instruments, but before going deep to the section, you need to know little bit geology, which is governing that geophysical things, because our ultimate aim will be to delineate the final geology. So you need to know, and it's also important for your upcoming geoscientist examination. So in this lecture I will talk about the features of fault, folds, and different type of structures, and some case study example through which we will deliver will show how this happens. So please, this is my channel, Physics and Geophys Learning. So let's move. So what is the introduction and mechanism of fold? So before going into this, you should know about stress and the strain. So stress strain I have discussed in my first seismic lecture series, which are all in continuation. So you should follow all that. The force applied per unit area, the compressive stress and the tensile stress, and the strain is the ratio of the change to the original length. Folds in general refer to the undulating structure which is formed when the sedimentary rock gets twisted, and which is due to the compressional stress. So different sedimentary rock can get twisted and bends, and the structures like hills, mountains can form. So this is one of the undulating structure. So this is one of the graph of stress versus strain. This following Hooke's law, within this elastic limit, stress is proportional to strain. When that exceeds this particular limit, there is a ductile field, and that happens in the Earth's crush mantle, and there is a fracture point. So this is one of the fundamental graphs you need to know, which I have already discussed in my first lecture. Still, for recapitulating, I have presented it to you. And the folding refers to the changes that occur below the surface of the earth. You can see there's an undulating structure. There will be different types of impermeable rock. There's a permeable reservoir rock, and there is a wall. There's a water. So this is one of the typical example of folds. You can see where you can have signatures of gas and oil. This type of structure must be present for having gas. This just for pictorial representation. So, and the fault is generally a detached plane formed when the rocks on the either side of the detachment or displacement that move past each other. So we'll thoroughly describe it. So when you are talking about fold and faults, you need to know in detail the compressional and the extensional field. So you can see when there is a stress is applied, the compressional, this regime, this color regime is the compressional regime. It gets compressed, and in this x direction the extension happens. So in y direction there is a compressional field, in the x direction there is a extensional field, so such that the folds happen. So due to the deformation in the strain ellipsoid, so it is the transformation from initial to final geometry by means of rotation on the translation. So you can see by the rotation and the translation, the rigid body, the volume change or the length change happens. And this is initially the mechanism of the formation of fold and the faults initial. So let's talk about the features of the fold pictorially. So this is nothing but a wave. You can see 3D wave structure. So in the waves, the flanks or the two sides of the fold are called limb. The two sides of the fold, they are called limb. We can witness the maximum curvature, and the hinge is that point that is joining the two flanks. Okay, that is called the hinge. And the axial plane is what? It is the plane where the hinge lines of different strata lies. So this is the full uh, folding procedure, the 3D structure. This is the hinge line. There is a two flanks. This is called limb. There is the inflection point from where there's a suppose positive to negative structure happens mathematically. This is the amplitude. You can see this is a wave amplitude, hub amplitude. This is the hinge zone, and you can see this is also the wavelength. The wavelength of the crest, the distance between two crest or two troughs. Okay, and this is the inflection point. So you know basic wave mechanism, so you can relate the basic wave mechanism to the features of fold in a 3D structure, so you can easily understand how the folds forms. When we are talking about the symmetry of the fold, there are different types of fold, as symmetrical, asymmetrical. So you can see in a symmetrical fold, the axial planes are called vertical, where in the asymmetrical fold, the axial plane is inclined. For isoclinal, there is a limb that are these limbs are parallel to each other, and it is parallel to the axial plane also. When you are talking about recumbent fold, it is a horizontal axial plane, and there is also overturned fold. It is like overturned fold. So it has highly, this inclination is very high on the axial plane, and the strata on one limb that are overturned. So this is called overturned fold. So based on the symmetry of the fold, there are different types of rotation, translation, deformation. So based on that, we classify different types of folds in geology. So when you're now main thing is there is a particular structure called anticline, where the various rocks inside the arch surface have been folded to form an arc. So fold may be upward or convex in shape. You can see the crest or hinge of the point is the biggest curvature. This is a crest or hinge of the point in the anticlines. It's called anticlines. The core, that means in the core in the anticline, consists of an old strata. When we are moving away further from the core, they are younger. So older to younger rock. So this is called anticline structure, and this is the maximum curvature points. When we are talking about syncline at the folds where the younger rock layers are located closer to the center of the structure. So these are downwardly convex in shape. So the core part of the fold is the younger strata, and the peripheral parts consist of the progressively older strata. So older to younger strata, and the core is a younger compared to the anticlinal structure. Okay. Now, classification of the fault plane. What is fault? It is the planes of detachment resulting when the rocks on the either side of the displacement slip past each other. It can be categorized as active or the inactive. So, even when there is a quick movement of the active faults, it releases an immense amount of energy, and which is the reason behind the more earthquake. There is two normal faults, reverse fault, classified under the drip ship fault. So normal fault is classified where the hanging wall is just displaced relative to the foot wall, which is the stationary. The hanging wall moves, but in a reverse fault, the hanging wall, this is the hanging wall that is moved upward in contrast to the normal fault. Okay. Reverse fault occurs due to the compressive forces, and the normal fault occurs due to the tensile forces. This is the main difference. And a down-thrown block between the two normal fault is called graben, and a up-thrown block between the two normal fault is called host. This host, graben, normal fault, reverse fault, this is a very common nomenclature of the any to interpret any seismic section. So I am describing whether you can easily understand seeing a seismic section. So fault, you can see there's a foot wall, there's a hanging wall. Displacement two sides, the hanging wall moves downward to the foot wall. The reverse fault is that hanging wall is moves upward to the foot wall. Okay. The thrust fault, that is the also compressional fault, and there is a trixie fault. These two blocks move past each other. This generally I have already talked about. This occurs due to the tensile and the compressive forces acting on the part of the crust. It is generally a fracture discontinuity along which the rocks on the either side has moved past each other. So this is the common definition of the fault. This is a very common definition. When you're talking about strike slip fault, there is a right lateral displacement, there is a left lateral displacement. So the fault plane is nearly vertical, and you can see when there is a rotation, you can see the rotation with the naked eyes. The rotation is clockwise, it is called right lateral. Rotation is anti-clockwise, this is called left lateral on the sinistral. Very easy. So this is a normal fault. You can see pictorial difference is a strike slip fault. Fault move past each other. The reverse fault, the hanging wall is upward the thrust wall. This is oblique fault. Obliquely move past each other, and there is a up thrown block between the two normal faults is called host, and the down thrown block between the two normal fault is called graben in a regional structure. So we now move to the, so we now show a one of the typically required seismic section occurred offshore during our GSI 2 field season for multi-channel seismic survey. You can clearly see the host and graben structure for that in the deep sea, and namely in the two cruises with so you can see. Oh, basement floors, you can easily see, and there is a horst graben structure. There is a trench axis is there, and there is a depression ridge, and depression ridges and depression, there's undulating structures which are very complex in the Andaman Sea. This is called the 90 East Ridge, and this is the sea floor, and this is the basement floor. And down below this structure, this is from SR 044, there is a sea bottom is there, there is a horst graben structure, there is a different sedimentary units and the sedimentary layer, unit 1 to unit 3. There is an anticlinal fold, you can see this anticlinal structure, there is a synclinal structure, there is a V-shaped valley, there is an Andaman subduction zone, there is a host, and there is a graben. So very complex geometry in Andaman's offshore region has been easily delineated by this geology and in a seismic section. So that's why I have previously described about this little bit of geology, so that you can get a feelings of seeing the seismic section easily, that anticlinal, synclinal on the horst graben structures are revealed in this in our lecture. Okay. So there is an interpretation of another seismic section, identification of faults and faults, and there is a references there for the GSI report. Uh, hmm, so there is a 4 units, 1, 2, 3, 4, that are described, and there is, you can see there's a volcanic intrusion is there, there is a basin, and there is a depression and undulating ridges. So very complex geometry. This is the valley, and the different depths and sizes and dimensions are described in this, and different types of reflectors with submerged ridges. There is acoustic basement is there. This OC means ocean continent boundary. So different types of synclinal anticlinal structure with folds and faulting nature have been revealed in this seismic section from GSI. This is a way with the acquired with the state of art instrument that I will describe in my any of my lecture of the seismic series, which are the instrument that are deployed to acquire such types of um, complex structure of the Andaman Sea region. And there is, I am also one of the participant of the cruise. So hope you have all enjoyed our lecture, and please, if you liked our lecture, please share, follow and comment, and turn on the bell notification icon. Thank you very much. Be with me, follow my lecture, and to get the more recent updates. Thank you.